This is the first video in a new topic that's going to look at crude oil and fuels. For this lesson and the following lessons, you will need to bring a sheet of paper and a pen to make notes and complete tasks that are put throughout the video. In this lesson, we're going to look at crude oil and alkanes. And by the end of the lesson, you will be able to answer the questions: how is crude oil formed? And what are hydrocarbons and alkanes? First of all, we're just going to start with some key words for this topic. So one of the key words is saturated. And this is a molecule that contains only single covalent bonds. You've also got unsaturated, and these are molecules that contain one or more double bonds. Now, you might have heard these words before, because sometimes in the media they talk about saturated and unsaturated fats. So you might have some familiarity with these words. You're also going to look at the word hydrocarbon, and that's going to come up a lot in this topic. And these are any compounds containing hydrogen and carbon only, of which alkanes and alkenes fit into this group. You might also hear me talk about a homologous series. And these are a group of compounds with the same general formula, the same functional group, and similar chemical properties. Now, you might be thinking, I don't know what a general formula or a functional group is, but don't worry, that will become clear as this topic moves forward. For today's lesson, you need to be able to answer and explain what are alkenes. So alkenes are a homologous series of saturated hydrocarbons with the general formula CnH2n plus 2. That was like a test of if I could get all the keywords into one sentence, but there you go. Right, what I'd like you to do is pause the video now and add to your notes the keywords and their definitions, and then restart the video. We're going to look at the formation of crude oil, and I'm going to show you a video. And while you're watching the video, what I'd like you to look out for are the answers to these questions. What is in crude oil? Where does it come from? And what is it used for?
Coal, oil and natural gas are fossil fuels. They were formed hundreds of millions of years ago when decaying plant and animal matter were buried under layers of mud, rock and sand which started to fossilise them. Although fossil fuels are made in similar ways, coal is made slightly differently from that of oil and natural gas. Coal was made mainly from trees and other plants, whereas oil and natural gas were formed from organisms living in fresh water, including plants and plankton. These fossilised remains were changed by the high pressures and temperatures under the earth to form the fuels we search for and dig up today. Natural gas is often found with oil, trapped between layers of rock. It is mainly methane, CH4, and is frequently used in our homes, piped underground to be used for cooking and heating our water. Coal is a valuable resource and is in great demand as a fuel for the use in power stations to generate electricity. It's also used in the production of steel and also in the manufacture of cement. Oil is especially valuable, and the reason for this is that it is actually a mixture of hydrocarbons. When oil is separated by fractional distillation, we are left with fuels useful for cars, lorries, planes, as well as chemicals used in the manufacture of a variety of different materials, including plastics.
I hope you enjoyed the video. Now let's have a look at the answers to these questions. What is in crude oil? Well, crude oil is a mixture of a very large number of compounds. Most of the compounds in crude oil are hydrocarbons, which are molecules made up of hydrogen and carbon atoms only. Where does it come from? Well, crude oil is a finite resource found in rocks. Crude oil is the remains of plants and animals, mainly of plankton, that was buried in mud. And over millions of years, with high temperature and pressure, the remains turned into crude oil. Now, it's important to not think that this process has stopped. This process is continuing now. But as it says there, it's a very slow process. It takes millions and millions of years for crude oil to form. So bear that in mind. And finally, what is it used for? Well, the chemicals contained in crude oil are incredibly valuable, and they're used to produce a range of fuels that you might use in cars, like petrol, and they're also used to make chemicals that are used to make polymers, like plastics. What I'd like you to do is pause the video and have a go at answering these questions. If you want a bit more challenge, you could use your revision guide or the online Caboodle textbook to add as much detail as possible to your answers. Once you're finished, play the video and we'll go through the answers. Okay, great. So here are the answers. Firstly, you were asked to describe how crude oil is formed. Crude oil is a finite resource found in rocks. Crude oil is the remains of plants and animals, mainly of plankton that is buried in mud. Over millions of years with high temperature and pressure, the remains turn into crude oil. Crude oil is also a finite resource. Explain what this means. Now, this links back to your previous topic on using resources, and you should know that finite resources are not formed quickly enough to be considered replaceable. So why is crude oil so useful? So if we look at crude oil and we zoom in on the chemical contained in that mixture, you have lots of alkanes and alkenes. And you're going to learn more about those as the lessons go on. And these alkanes and alkenes are the starting materials to make plastics or polymers and fuels like petrol or diesel. And that is why they're so valuable, because we use them all the time. I bet there is something that you have done today that has involved a plastic or a fuel. Even if you've not been in a car for a while, your food has been delivered to the supermarkets using fuels in the vehicles. So it's integrated into our everyday lives. Right, alkanes. Crude oil is a mixture of lots of different chemicals, and nearly all of them are made out of hydrogen and carbon, and they are known as hydrocarbons. Some of these are carbon chains called alkanes. And here's an example of an alkane that contains 6 carbons, and it's called hexane. Now let's look at the structure of alkanes in a little bit more detail. Now here I have an alkane that's called ethene, and it contains 2 carbons and 6 hydrogens. Between each of these atoms are straight lines. So we've got a straight line here between a carbon and hydrogen atom, and a straight line here between 2 carbon atoms. Now think back to your structure and bonding topic. These straight lines are showing covalent bonds between the carbon and hydrogen, or the carbon and carbon. So we could draw them another way using a dot and cross diagram, but we like to simplify it just to make it easier when you're drawing bigger molecules. And don't forget that each line represents a shared pair of electrons. You need to know the name, formula and structure of the first 4 alkanes in the homologous series. The first one is methane, then you've got ethane, then propane, and then butane. And each time the number of carbons increases by 1. Now, to help you remember these words, because they might appear new to you, you could use this little memory tool. My elephant prefers bananas. Methane, ethane, propane, butane. Please notice that the end of all of the words is the same. They finish in A-N-E. And that tells you that you have an alkane. They match up. The name of the homologous series and the end of the word, A-N-E. If you know the number of carbon atoms in your alkane chain, you can work out the chemical formula of any alkane using a general formula. And the general formula for alkanes is CnH2n plus 2. So for example, if you had 2 carbons, it would be C2, and then hydrogens, it would be 2 times 2, 4, plus 2 more, 6. So for ethane, you have C2H6. You need to learn this formula so that you can apply it, and I will give you some practice of this. So what I'd like you to do now is pause the video, copy and complete this table in your notes. And if you'd like a challenge, you could add an extra row and predict pentane. Now take a close look at the name. Pent at the beginning of a name is something you might have heard of in maths as well. So have a think about it. Press play when you're done. Great, so your table should look like this. Every time you move down a row, the number of carbons is increasing. And you need to make sure you have the correct molecular formula and displayed formula. Now, if you've tried the challenge and had a go at pentane, you should have 5 carbons. And you use the prefix pent for things like a pentagram or a pentagon, meaning something with 5 sides. And so pent is the prefix for 5. Right, that's the learning done for today. So I've got a little quiz here for you. There's a series of questions that are multiple choice or maybe short answer. Have a go through all the questions, write down your answers, and then the answers will be at the end. Good luck. Question 1. Is crude oil A, an element, B, a mixture, or C, a compound? Question 2. Name 2 products that can be made from crude oil. Question 3. Crude oil contains A, alkanes, B, alkrams, or C, hydranes? Question 4. If there was a carbon chain with 12 carbons, how many hydrogens would it have? Here are your answers. Crude oil is a mixture. The 2 products that can be made from crude oil are fuels and plastics. Crude oil contains alkanes. And to calculate the number of hydrogens in a 12 carbon chain, you need to use the general formula, and the calculation is shown on the screen for you. That's the end of today's lesson. See you again for the next one in our series.